So a lot of people are going to struggle with this unusual geometry problem, but I'm going to tell you right now that the solution is not that difficult. Matter of fact, as long as you understand basic geometry, you should be able to solve this problem. Okay, so what do we have here? Well, we have two squares, and each square is 10 centimeters by 10 centimeters. Now, what we're looking to do here is find the area of the overlapping region between these two squares. Now, obviously, one square is on an angle, but the key information that we do have here is that the corner of this square right here is in the center of this square. All right, so that's really important. But this is all the information that you need in order to figure this out. Okay, now feel free to use a calculator, but if you have an answer, go ahead and put that into the comment section. Then, of course, I'm going to walk through step by step on how to solve this very interesting geometry problem. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoyed this content, make sure to like and subscribe, as that definitely helps me out. Okay, so again, we have two squares, so the dimensions of these squares are 10 centimeters by 10 centimeters. Now, what we're looking to do is find the area of this overlapping region. Okay, and I'm going to show you a better kind of a diagram here in just one second, but it's this area right here. Now, a key piece of information that we have is that the corner of this square is in the center of this square right there. Okay, so I'm going to give you a couple quick formulas, or actually, I'm going to give you the formulas because I don't think that even if most of you out there have the formulas to, solve this problem, again, that's the kind of easy part. The hard part is figuring out how to use these formulas. Okay, so the first is, let's talk about the formula for the area of a square. Now, if you forgot that, I'll go ahead and give that to you right now. So the area of a square is what? Well, it's the side squared, right? So that's one area that you want to, or one formula for area that you want to think about. Now, another formula is the area of a triangle, right? So you're going to need this formula as well. So that is equal to 1/2 base times height. Okay, so hopefully most of you are saying, yes, Mr. YouTube Math Man, I understand that. But what I'm most interested in is the area of this thing right here. Well, what is this thing? Okay, just kind of visually kind of take a look at it, and you might be saying, well, it looks like a trapezoid. Well, actually, that's not a trapezoid. So if you were thinking trapezoid, that's not correct. This is just a quadrilateral. Okay, so let me kind of show you this right now. So the way this thing looks like is kind of like this. Okay, now why is this not a trapezoid? Now, that's a really poor diagram. But the reason why this isn't a trapezoid, because it's pretty clear by the diagram that we don't have two parallel sides, okay? So in order to have a trapezoid, you need to have two opposite sides that are parallel, and then of course you can have two angles like this. Now a trapezoid is a type of quadrilateral, okay? And there is a formula for the area of a trapezoid, and you're going to need that, and let me go ahead and give that to you right now. So if this length here is A and this length there is B, okay, these are our bases, and then we have a height of that trapezoid. The area of a trapezoid is 1/2 A plus B times the height of the trapezoid. Okay, so this formula is one that we're going to need as well. And matter of fact, we're going to need all these formulas. But this thing right here, again, is not a trapezoid. So you're like, well, if I did have a formula for this, well, I could just plug in the information and figure out the area. Well, it's not going to be that easy. Okay, so again, this is just a quadrilateral. By definition, to have a trapezoid, you need two sides, two opposite sides that are parallel. Okay, so hopefully you're like, all right, Mr. YouTube Math Man, I got all the formulas, but I am still pretty thoroughly confused. Well, again, as I indicated, I think a lot of people, even if they know a lot of geometry, are going to kind of struggle with this problem at first. But don't give up because you can't figure this out. All right, so let's go and take a look at the actual problem, and here's kind of a easier way to see it. So we got to keep in mind that the corner of this square right here is in the center of this square. All right, so that position right there is in the center of this square. Now, what do we know about squares? Well, we know that these are right angles, so I don't want to put in all this notation right here, but all of these are 90-degree angles, and all the sides of the squares here are equal. Okay, so I'm going to go ahead and just assume that you know that. And let's just kind of keep these diagrams nice and neat. So looking at this, you're like, well, all right, Mr. YouTube Math Man, what information can I discern about this situation right here? In other words, I want to find the area of this. Well, what information do I know? Well, do I know this length right here? Okay. Matter of fact, I don't even know if I could use that length, but do I have this length? Well, I do not. Okay. The diagram is not showing me that length. I don't have this length as well. I don't have this length, and I don't have this length. So you're like, hey, Mr. YouTube Math Man, this is quite confusing, but hopefully some of you are saying, well, we do know this length from there to there, okay? From here, if this is the center of the square to the side of the square, this is going to be 5, right? It's going to be 1/2 of the side of the square, right? Because the center is basically going to bisect the length of the square, okay? So hopefully most of you are saying, well, we do know from here to here that is 5, and that distance is also going to form a right angle. Okay, so we kind of have this situation right there. But outside of that, you might be saying, well, I don't really know, how to approach this problem. Again, as I indicated, most people are going to be confused on how to figure this out. Now, some of you hopefully are kind of thinking outside the box, no pun intended, and you might say, well, if this is in the center, let's keep that in the center, and let's imagine that we just kind of grabbed this square and we kind of swung it down in an arc, right? In other words, we took this square and we kind of swung it this way, right? We kept, we just kind of turned it, maybe turned it into this position right there. What would happen? Well, this is what would happen. Okay, so basically we would end up with a situation like this. Okay, so we would have our square in this position. Now, of course, this is not the problem, but let's just go ahead and figure out the area of this situation. So here is the center out to the side. That is going to be 5. Now, because this is a 90-degree angle, right, from here to here, that's 5 as well. So this area right here, this box is what? That's a square. 5 times 5 is 25 centimeters squared, which is the correct answer. So you might be saying, that's interesting, Mr. YouTube Math Man. Is that how we solve the problem? Well, this is one approach, right? We kind of have to, maybe apply some theories. Now, some of you may have solved this problem in a completely different way, and that is fantastic as well. But I'm going to just kind of show you some different approaches that you can think, or different kind of strategies that you kind of reason through to get the right answer. So maybe if we swung this square, okay, into a different position, keeping this corner in the center, we can get the area. But how do we know that this area is in fact equivalent to this area right here? Well, we don't know, right? In fact, we do know the answer, and the answer is 25 square centimeters. But we might be like, well, I'm not quite sure. So maybe we want to kind of swing this square into another position and see what happens. Now, what's interesting about this area right here, it's 1/4 of this bigger box, right? So 10 times 10 is 100, and 1/4 of 100, of course, is 25 centimeters squared. But what we could do here is actually swing this square maybe in a different position where we could calculate the area. So let me go ahead and tell you, or show you what I am talking about. So let's swing this square this way. Okay, so instead of down like this, we'll go ahead and swing it like to the left, right? So we'll kind of swing it up this way. Now, let's have that square, okay, right here. Remember, this is still in the center, but now, because this is a 90-degree angle, it's kind of going to go through the corners of this other square, all right? So again, we have a 90-degree angle, and we can just kind of, sketch this out and imagine this. But now, what information do we have? Well, we have a triangle right here, right? So this is a triangle. And do we have the dimensions or do we have enough information to figure out the area of this triangle? Well, in fact, we do, right? Because from here to here is 5, right? The height of this triangle is 5. Matter of fact, let me erase this right here so you can see a little bit better. So from here to here, that is 5. And we know the base, right? The base is the side of this square right here. So that is 10. Okay, so what's the area of this triangle? Well, it would be 1/2 base times height, which is 10 times 5. So 1/2 times 5 times 10, or 10 times 5, of course, is 50, which is 25. So we came up with the same area again. So this is pretty exciting. You're like, well, that's fantastic, Mr. YouTube Math Man. But, again, we're not solving the problem, the original problem, which is the square in this position, right? We're not going through the corners. We didn't kind of, turn it. How do we figure out the area right here, right? So here it's 10 by 10. I'm just going to go ahead and just highlight this. So we have this distance right here and this distance right here. So how do we get to this area? Now this area is 25 centimeters squared. So it's the same as us turning the square, but how can we kind of basically confirm this? Now, before we continue on, if you want to get better at math, you definitely can, but the key is to find a teacher that gives you clear and understandable instruction. So hopefully you like my teaching style, and if you do, if you're like, yes, I think I can learn from you, well, then you will love my full main math courses. So you can find the links to all of these courses in the description, but they include basic math, pre-algebra, algebra 1, geometry, algebra 2, pre-calculus, and a ton of specialized test prep math courses. Okay, so again, don't give up if you're having a tough time in math. I can definitely help you out. So you can check out the links to all these courses in the description. So let's get back to the video. So how can we figure out the area of this region? Okay, so let's go back to this position, right? So we had this square like so. Okay, so it's going through this angle. Now, let's just do something very carefully here. So if I move this square, again, I'm going to keep this corner in the center. If I start moving it down, right, kind of arcing it clockwise this way by in other words, it's basically going to be kind of, swinging from this position. What's going to happen? Well, it's going to start slowly turning this way, right? So it's going to kind of start doing this. But what we want to observe is whatever amount that I turn right here, or when I turn the square this way, you can see there is a distance right here, okay? Well, that distance is going to be the same as this distance, right? So as I continue on, this distance is going to be the same because we're talking about right angles. Now, eventually, we're going to have the same exact distance because this distance and this distance right here are the same, right? Because basically we have a perfect square within this square. So hopefully that makes sense. You might be, hey, Mr. YouTube Math Man, I'm thoroughly confused here. Well, let's go ahead and see if we can kind of clear things up. So let's suppose I turn the square just a little bit and we open up 2 inches right there, okay, or 2 centimeters rather, right here. Now, we can use any number like 1 or 2 or 3, but I'm just going to call this 2, all right? So let's say this square, we just kind of turn it enough to the right where we have 2. Well, if we have 2 right here, we're going to end up having 2 right here, okay, on this side right there. So whatever this distance is, it's going to be the same distance because, again, this corner of this square is in the center of this square. So this requires a little bit of imagination. And if you didn't see this, well, this is going to be the key to kind of confirming, calculating the area. Now, we already kind of figured out the area in 2 different ways, but this is the approach that we really do need to take in order to kind of verify that, in fact, the area of this region is 25 centimeters squared. All right, so this is a big clue. Okay, now this should be hopefully enough for most of you to use all the information that I gave you to figure out the problem. Okay, so let's go ahead and take a closer look. So here is the situation, all right? So if I turn this square a bit, there's 2 centimeters right here. There's going to be 2 centimeters right here. Now remember, this distance from here to here is 5, right? Because we're in the center. So we really have to take a real close look at what's going on here. So from here to here is 5, from here to here is 2, from here to here is 2. Now if this distance is 5 right here, okay, and this total distance is what? Well, from here to here, it's 10, right? This is 10. Well, if we take 10, and we have our 10 and we subtract 2 away, what do we have? We have 8 right here, right? So this is 8, this is 2, okay? And you're like, Mr. YouTube Math Man, this is very confusing. Well, you got to stick with me, right? So from here to here is 5, okay? But this distance right here, it splits half of this side. So this side is going to be 5, this is 5. So if this is 5 and this is 8, well, this is 3. Now, most of you at this point are like, hey, Mr. YouTube Math Man, my hair is thoroughly, confused. I got smoke coming out of my ears. Well, I totally get it. But again, this is what you need to do in order to figure this problem out, okay? So let's go ahead and take a look at this information this way. All right, so here it is. Hopefully this makes some sort of sense. You got to study this because, it's not so easy to see the first time out. Now, again, if this is 2 right here, this becomes 2 down here, okay? Now we have this quadrilateral, but what we can do is split this quadrilateral up into 2 pieces, okay? One is a triangle. Right there, that is a triangle, all right? So we can find the area of a triangle, and this right here is a trapezoid, okay? It's a trapezoid because we have 2 sides that are parallel to one another. So this side right here is parallel to this base. So if we kind of break it out right here, from here to here, this is 5, and from here to here, this is 2. But the key here is that these sides are parallel, right? Because from the center to the side is going to be perpendicular to this side right here, right? And of course, this perpendicular side is going to be parallel to the other side of the square. So we do have a trapezoid right here. So this side is 5. This side right here is also 5 because this is 3. Now, again, this is very confusing, but you got to study this figure. And what we're doing here is really confirming that, in fact, we do have the correct area for this region. Okay, so what we can do is find the area of the triangle and add it to the area of the trapezoid. Now we have enough information to actually calculate the area of this region. So let's go ahead and do that right now. All right, so here is our triangle. Okay, so the area of this triangle is going to be 1/2 base times height. So the base is 3, the height is 5. So we'll calculate that in just 1 second. But here is our trapezoid. This is a little bit hard to see, but 2 sides, remember our base sides here are parallel to one another. Okay, so this 2 and this 5. We have to go back up here to study this figure. So this 2, this side right here, the trapezoid, and this side are parallel. And this is 5, this is 2, and this height of this trapezoid is 5. So we're talking about a trapezoid with the height of 5 and 2 bases that are a base of 5 and another base of 2, okay, and a height of 5. Okay, so we got a lot going on here, but we're just about ready to kind of, pull this all together. All we have to do is find the area of this triangle and add it to the area of this trapezoid. And let's go ahead and take a look at the actual information and the actual values and see if this works out to be 25 centimeters squared. All right, so the area of this triangle is 1/2 base times height. The area of this trapezoid is 1/2 a plus b, where a and b are our bases. Okay, so this could be A, this could be B, and our height is 5. All right, so let's go ahead and plug in all the respective information. So the area of the triangle, pretty easy, 1/2 base times height. That again is 5 times 3, so that's 1/2 times 15, or 15 over 2, right? Because 1/2 times 15 is 15 halves. And the area of this trapezoid is 1/2 5 plus 2 times 5, or 1/2 of 5 plus 2 times 5. So the order of operations, we've got to do with what's inside the parentheses. 5 plus 2 is 7. 7 times 5 is 35, so this is going to be 35 over 2. Okay, so let's go ahead and add these two fractions, and hopefully this works out. So 15 over 2 plus 35 over 2 is 50 over 2. 50 divided by 2 is 25. So the area of that region is indeed 25 centimeters squared. If you need additional help in geometry, check out these courses right here. So in my pre-algebra course, I have a couple of chapters on basic geometry, but if you have to understand all things geometry to include proofs, then you got to check out my full geometry course. Now, if you want a good math review of basic math, algebra, and geometry, then check out my Math Skills Rebuilder course. All right, so I'm going to leave links to all these courses in the description of this video. And with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.